Okay, guys. So we're going to be doing inference as our topic for this week. So I'm going to be going over the free response from the 2012 exam, question number 4 that I assigned to you. So just reading the question, it says a survey organization conducted telephone interviews in 2008 in which 1,009 randomly selected adults in the United States responded to the following question. And the question says, at the present time, do you think television commercials are an effective way to promote a new product? And of the 1,009 you adults surveyed, 676 responded yes. And in December 2007, 622 of the 1,020 randomly selected adults in the U.S. had responded yes to the same question. So do the data provide convincing evidence that the proportion of adults in the United States who would respond yes to the question changed from December 2007 to December 2008? So the question says, does the data provide convincing evidence? So that's my clue to do a test versus a confidence interval. So remember, if they're talking about does it provide evidence, it's a test versus a confidence interval. So then I just have to decide means or proportions. So since we're talking about a certain number of people responding yes out of a total sample size, this is going to be a proportion. And then once I know its proportions, I'm going to decide is it one sample or two sample. So the reason that this is a two sample is because you had this sample from December 2008 where they randomly selected these people, and then you had it in another sample in December of 2007 where they randomly selected the people. And they want you to compare the two independent samples. Okay, so that's why it is a two sample test for proportions. So that's the first thing to decide, and now we'll get to the logistics of the problem. So as usual, we are going to start with population and parameter. So remember, since this is a two sample test, I have two different populations. My two populations are US adults in 2007 and 2008. So it's really just the two different years. My parameter is, remember to use the word proportion who think TV commercials are an effective way to promote a new product. So that's my populations and parameter. And then as I kind of mentioned on the front, this is a two sample z-test for P. Remember, proportions are always a z. What are the conditions for the two sample z-test for P? Well, the first one is both of your samples should be in SRS. So if we look back at the question, it says right here, randomly selected. Okay, so SRS is a check and given. Okay, approximately normal. Okay, so I have the work for the approximately normal right here. The way you check approximately normal is n times p and n times 1 minus p have to be greater than or equal to 10. So just as a reminder, since this is a two sample z-test for p, what I have to do is I have to get the pooled proportion. So for that, we use this p sub c hat is what stood for the pooled proportion. How do we get the pooled proportion? Well, we add our denominators, we add our two sample sizes together. So this is n sub 1 plus n sub 2. And then the numerator is the number in each sample that meet the criteria. So in this case, 622 in the one sample said yes, and 676 in the other sample said yes. So I add those two together. So this is x sub 1 and x sub 2. That's how you'll see it on the formula sheet. And remember, you don't need to memorize anything. They're assuming the test is open book, open note. So just remember, that's how I get this 0.6397. So, and this is you only have to do pooling if it's a two sample z-test. Okay, only for a test, not a confidence interval. So that's how I check approximately normal. All those have to be greater than or equal to 10. My third condition is, maybe I'll just draw an arrow here so you guys can kind of see that. That goes with that. Independent, my two independent samples, 2007, 2008, we kind of talked about that already. And then just remember that you check your population is more than 10 times your sample size. Okay, and you should check that for both years. So this is for 2007 and 2008. Okay, so those are my conditions, and that's how you get the pooled proportion. Okay, now we're going to get into doing the test. First thing we're going to want to do is write the ho and the ha. So Anytime you're doing a 2-sample test for proportions or Ho, you always assume the 2 proportions are equal. So P sub 1 equals P sub 2. And then the alternative depends on the wording of the question. So if we go back to our question here, do the data provide convincing evidence that it has changed? So since we're just checking for a change, it's just going to be not equal to, as opposed to greater than or less than. And then I just made my P sub 1 be 2007 and my P sub 2 be 2008. You could reverse those, okay, but make sure you say which one is which. Okay. So then once I have the Ho and the Ha, I'm going to have to get a Z-score since this is a Z-test. So I have all the work here. So just as a reminder, if you're looking for a formula, this is the formula for the 2-sample Z-test for P. P sub 1 hat minus P sub 2 hat, and it's over the square root of that pooled proportion, which we just talked about, times 1 over n sub 1 plus 1 over n sub 2. Okay, so that's where I got these two guys. This 0.6098 and this 0.67 came from dividing. So like for the first one, I did 676 over 1009. Okay, that's my P sub 1 hat. For the P sub 2 hat, I did 622 out of 1020. Okay, so that's where, or I'm sorry, this is P sub 1, this is P sub 2. But that's how I got them, was just dividing. Okay. And again, you could reverse these. And then this is the pool proportion from up here, and these are my 2 sample sizes, 1020, 1009. So if you plug all of that into the calculator, your Z-score is negative 2.82. Okay, so since this is a not equal to test, I'm going to get the area on both sides. So I'm going to get the area from negative 2.82 and below and from positive 2.82 and above. So just as a reminder, on your calculator, you can just find one of them and then double it since the normal curve is symmetric. So I just did normal CDF from negative 99 to negative 2.82, and then I'm multiplying it by 2. So there's my P. And once you get the P, remember if the P is low, reject the Ho. They do not give us an alpha to use in this problem. So remember the standard cutoff if they don't give you one is 0.05. So I'm just going to say my P is less than or equal to alpha of 0.05. So we're going to reject the Ho. So just, again, make sure you're rejecting the Ho. We're rejecting that they're the same, and we're going to have evidence that they're different. So you can see how I wrote that out. We reject that the proportion of U.S. adults who think TV commercials are effective in 2007 and 2008 is the same. Okay, reject the Ho. If you reject the Ho, you have evidence towards the Ha. So we have evidence that they are different. So that is 2012, number 4. All right, I'll talk to you guys again soon.